Hey folks, in this presentation I'll be giving you a brief overview of ORES, a socio-technical system for supporting the participatory machine learning model building and usage in Wikipedia. And I'll be discussing one example of how ORES is being used by lay users to design, evaluate, and critique uses of machine learning in their context. Wikipedia is an interesting context to explore participatory machine learning for several reasons. Wikipedia is a self-directed community of volunteers who set their own editorial guidelines for the encyclopedia. They also set guidelines for the production and use of technologies that support Wikipedia. A large subcommunity of volunteer tool developers build robots, web services, and JavaScript gadgets that extend the functionality of the wiki software, and these tools provide support for community-designed workflows and processes. Machine learning has become an important infrastructure for Wikipedia because of the way that it enables processes to scale to the firehose of activity that is the world's largest encyclopedia. ORES is designed to broaden access to these machine learning technologies. As an intervention, ORES provides access to high-performance and high-fitness machine learning models, but does not direct developers on how to use them. For example, a tool developer might use a damaging edit detection model to support counter-vandalism work, or they might turn the model upside down and use it to highlight good-faith new contributors. This dynamic decouples the process of building high-fitness models from the process of designing user experiences that make use of the models, and this affords greater expressiveness and new experimentation opportunities for tool developers without the time or expertise to build their own models. The technical components of ORES consist of a model-building framework that is designed to extract features from Wikipedia and train predictive models. The system also provides a service for hosting models for high-performance, real-time access. We designed the service to provide a familiar interface for Wikipedia's community of tool developers by matching the interaction patterns of the MediaWiki API, the primary source of data and actions that tool developers worked with before the introduction of ORES. A user makes a request to the service via HTTP. For example, this request asks ORES to predict whether this edit to the article about dog intelligence caused damage, and ORES responds with a human-readable JSON document containing the prediction. But ORES is more than a technical system. ORES is supported by the scoring platform team, our engineering and research-driven team at the Wikimedia Foundation. All of the models made available via the ORES system were designed and trained in collaboration with various communities of Wikipedia. For example, article quality models in ORES were designed and trained differently for Portuguese Wikipedia than they were for English Wikipedia. We also redesigned components of the ORES service in collaboration with tool developers to make the service more flexible and easier for them to configure. This paper contains a collection of demonstrative cases, stories from the field that demonstrate how volunteers with mixed backgrounds were able to design, use, interrogate, critique, and even collectively make sense of how machine learning should and should not be used in their collaborative workspaces. These cases paved the way for a new set of conversations regarding how we might think about issues of fairness and power dynamics around algorithms operating in social spaces. For the purposes of this video, I'll tell one story, the case of Participatory. One of the most critical problems of scale in Wikipedia is counter-vandalism work. As the open encyclopedia that anybody can edit, Wikipedia is equally open to both productive and unproductive changes. In order to ensure that Wikipedia doesn't fill up with vandalism, edits need to be reviewed. Spanish Wikipedia gets about 24,000 edits per day, which is a massive reviewing workload. A tool developer in Spanish Wikipedia saw an opportunity to use ORES damage detection model to design a bot that automatically removes damaging edits. This bot, Participatory, was deployed in Spanish Wikipedia, but soon after, complaints started rolling in. Many newcomers who were doing good work were getting reverted by the bot, and they didn't understand why. In response, Spanish Wikipedians organized an edit labeling exercise to determine how often Participatory was making mistakes and a community discussion about what rate of mistakes they would consider acceptable. Ultimately, they determined that Participatory was making too many mistakes, and they decided to take the bot offline. This case is interesting for many reasons. Participatory's developer was able to design an intelligent user experience despite a lack of formal education in machine learning concepts. The Spanish Wikipedia community were able to evaluate the use of the ORES model in the case of Participatory, essentially answering questions about precision and recall without using formal terms. Because ORES is decoupled from the user experience of Participatory, and Participatory was governed by the local community policies, the community was able to decide to shut down its activity without petitioning our team or anyone else. The power remained in their hands, and that's part of the reason why we think decoupling is an important contribution to discussions of fair and transparent machine learning systems. That's all the time I have. I hope you'll consider checking out the other cases we discuss in the paper.